Hi dear students, welcome to my channel. In this video, what we discuss elastic properties of solids. Okay? Elastic means if you apply external force on an object, what happens? Its shape changes. Its length may change. It may undergo some deformation. Now you remove the external force. It will regain its original shape. This is called elastic nature of material. Okay? This is elastic nature of the materials. In this class, means in this video, the elastic properties means what? Before going to tell elastic properties exactly, what is happening when you are applying external force on a solid? You take any object. You take this. On this object, I am applying some force. Okay? I am holding one side. I am applying this force along this direction. What you are finding? It remains same. If you take a spring, you compress it, then what will happen? You can very well identify that the length is decreased. But here, you are not feeling that its length is changed. But in fact, the length of this object also decreases when you apply external force. But that is very negligible. Okay. Then why it is so? Why it is so? Ultimately, the atoms means any solid is made up of atoms. In solids, the distance between the atoms remains fixed. Okay? So when you are applying external force on the solid, the distance between the atoms decreases. Because of this, one internal force build up in the solid that will oppose the external force. That is the reason when you are removing the external force, it will regain back its shape. Understand? Okay. Now, we'll come step by step. This is a solid. This is cross-section area. Cross-sectional area of solid. You assume it is fully solid. Cross-section area. This is the surface. Now I am applying force perpendicular to the plane. This is the plane. This is the surface. I am applying force perpendicular to this. This force per unit cross-section area, force per unit area, I am calling that is stress. Okay? So this stress is proportional to applied force. Okay? Because of stress, what is happening in the material? It is undergoing deformation. Means its length change. So change in length per initial length. Change in length divided by initial length. Suppose initially it is 10 centimeter. After compressing, it has become 9 centimeter. I am giving an example. So 10 minus 9, 1 centimeter. 1 centimeter divided by original length, that is 10 centimeter. So 1 centimeter is change in length divided by 10 centimeter, that is the original length. That is called strain. Why strain is coming? Because of stress. What is the stress? I told. So this strain is changing as per the stress. So this stress is proportional to the strain. Means higher the strain, higher the stress. Agree or not? So this stress is directly proportional to strain. Stress is directly proportional to strain. So stress is equal to, you can write one constant E into strain I am writing. Then E is equal to stress by strain. This E I am calling elastic modulus. Elastic modulus. This is the general discussion of a solids. E is elastic modulus in general. This E is different for different material. E is different for different kind of deformation. The deformation may be change in length, deformation may be change in shape, deformation may be change in volume. Based on type of deformation, like change in length, there is one modulus, that is Young's modulus. Change in shape, there is one modulus, that is shear modulus. Change in volume, that is another modulus, that is bulk modulus. Okay, elastic modulus is a common entity, common topic, based on material, based on deformation. Three types of modulus. We'll discuss one by one. Okay. First one is Young's modulus. Y-O-U-N-G-S. Young's modulus equal to tensile stress divided by tensile strain. What is meant by tensile stress? This is for change in length. This Young's modulus measures, it is resistance to change in length of the solid. Means, if I am giving Young's modulus is some value, some 20 into 10 to the power of 10 Newton per meter square. What does it mean? It will resist to change in its length. Young's modulus is saying that. So when you are applying the force like this, there will be change in length. So this stress is called tensile stress. Change in length by initial length is tensile strain. You got it? Now we will discuss shear modulus. Actually, this Young's modulus useful for lengthy objects, like to construct a building. We will first build the pillars. No, in the pillar they will use iron bars. So they will first find out what is the Young's modulus of that material. It should be enough to hold to a huge weight. No, how many stores you are going to build? 10 floors or 15 floors or 6 floors. Depending on that, you have to choose the material which can withstand for this tensile stress. So that is application. Indirectly we are going which type of material you can choose to build one building. You are understanding, no? Okay. Next, second one. We go for shear modulus. Shear modulus means, so in the previous you are applying the force, this is the surface, no? Perpendicular to the surface you are applying the force, that is the tensile stress I told. Now it is force you are applying tangential, means parallel to the surface. So this is the book. Okay, this is the surface. On the surface, parallel to the surface, I am applying the force. This is the original shape. You are able to visualize original shape. This shape you are seeing like this. No, I am applying the force tangentially. Then shape changed. Shape changed. How it changed? I will draw this. Originally you are seeing like this. Originally you are seeing like this, without force. Now I will apply the force on it along this direction. the down, the bottom portion is fixed. Because of this force, opposite direction में a frictional force आता है, that's why this is fixed. So because of this force, the shape changes like this. The shape changes like this. Agree? You are able to see. So this is sheared like this. So this is del x. This height is h. This del x divided by h. This is called shear strain. Shear strain. Okay? This force F I applied, no? F divided by the surface area. I told you this is surface, this surface area divided by area. This F is a force acting tangential to the surface. So this is shear strain. No, this is strain. This is stress. Shear stress. This divided by this. That is shear modulus. S is equal to shear strain divided by shear stress. Sorry, shear stress divided by shear strain. So F by A. This is shear stress divided by shear strain. Del X by H. You got it, no? Okay. Third one. Bulk modulus. Bulk modulus. Okay, clearly note down. Bulk modulus means force applied on all sides. This is a duster. I am applying force here, from bottom, from top, from left. In all the direction force is applied. You are compressed. When it happens? Did you swim? Can you swim? Yes. Why I am telling this? If you go deep into the water, there is a pressure on you. Okay? Force is equal to pressure into area. You know that? I am taking one three-dimensional object. Take this like this. Here, in all directions, force is here. Force direction is this. Force direction is this. Force direction is this. Force direction is this. Okay. In this situation, it will be compressed. Compressed. Agree? If you drop this object inside the sea, if it go deep inside maybe some 100 meter, the pressure at the 100 meter depth into area, that is the force. So volume changes. So bulk modulus B is equal to, here the force per unit area. Force per unit area is what? Pressure. Okay? If force changes, pressure changes. So I am calling that is delta P. Change in pressure. If pressure increases, volume decreases. So del V, change in volume by initial volume. Here minus I have to keep, because if pressure increases, volume decreases. If this is positive, this will be negative. So minus into minus plus. If pressure decreases, delta P negative होता है. Then volume increases. Then minus into minus plus. To make this B always positive, I am writing minus sign. Okay. Now bulk modulus, once again I will explain. This is you can use when one particular object is deep inside the water. So because of the total volume shrinks. This is the bulk modulus. You got it now? Okay, if you like this video, please like it and share this video and subscribe my channel and tap the bell icon to get the notification for further uploads of my videos. Thanks for watching. Bye bye students.